Welcome to a little video on how to solve quadratic trinomial equations. This is part 1 of 3, and we're only looking at the simpler of quadratic trinomial equations where the solutions are going to all end in integers or whole numbers. And it's important to note that we're talking about equations of this form where A, B and C are what we call real numbers. In the first video, A is always going to equal 1. Well, you're not going to see it at all because when the coefficient of x squared is 1, we just leave out the 1, don't we, because it's not needed. But you'll also find in this video that B and C have whole number values or integer values. Okay, and we're going to use what's called the PSN method to solve these equations. P stands for product, S stands for sum, N stands for numbers, and we're going to see right now how that works. Let's have a look at our first example. We're going to solve for x in this equation here. X plus x squared equals 6. Well, the first thing to note is that our equation is not exactly in the form we saw on the previous, just a minute ago. So what we're going to do is subtract 6 from both sides. Okay, so we're going to let x squared plus x minus 6 equal 0. Now, here's where we use the PSN method. P stands for product. What we mean by that is that you multiply the coefficient of x squared, which is 1 in this case, and in all cases in this video, 1 by the constant term, by the negative 6 in this case. Okay, so the product means times, of course, so we're going to multiply 1 by negative 6, 1 by negative 6, and that of course equals negative 6. Sum, we're going to see why it's called sum in a minute, but for the moment all you need to know is that it is the coefficient of the middle term. So the coefficient is the number before the pronumeral. Well, there isn't a number before the pronumeral here, is there? So it's taken to mean that it must be positive 1. Okay, so the sum is 1. Okay, now here's the guessing game. We've got to think of two numbers that when multiplied, whose product that is negative 6, but when added, we'll say so the sum of which is 1. And we can do that in various ways, but here it's fairly straightforward. Our numbers are 3 and negative 2, because 3 times negative 2 equals negative 6, and 3 plus negative 2 equals 1. One way to do it is to list all the factors of the product here. So let's do that just by rough working. What are the factors of 6? Well, 1 and 6 are factors, and 2 and 3 are factors, aren't they? So we multiply 2 by 3 to get to 6, don't we? And there are all sorts of positive and negative cases. I'm not so worried about listing those at the moment. But let's have a look at this. The fact that the product is equal to negative 6 is indicating that one of our numbers must be negative. Why? Because a negative times a positive will give a negative. And the fact that the sum is positive 1, means that the larger in magnitude must be positive, sorry, because the sum is positive. Okay, let's think about this. 1 times 6 is 6, and 1 times negative 6 is negative 6, so it gets us that. But if it was 1, negative 6, if the two numbers were 1 and negative 6, well, 1 plus negative 6 is negative 5, so we can forget about that. What about 2 and 3? 2 times 3 is 6, so that's no good. So 2 times negative 3 would be negative 6, that's good, but 2 plus negative 3 would equal negative 1, so that can't be right. So maybe it is negative 2 and 3 that we want. Let's check it out. Negative 2 times 3 is negative 6, and negative 2 plus 3 is indeed equal to 1. So there are our numbers there, and that explains how we get them here. So once that happens, our work is very easy indeed. All we need to do is write down x plus 3, that comes from this number here, and then x minus 2 like that equals 0. Okay, now we haven't quite solved our equation, have we? But we're going to rely on what's called the null factor theorem at this stage, and the null factor theorem states the following: that if A, whoops, we lost it there. If A times B equals 0, either A must equal 0 or B must equal 0. What are we saying there? Well, have a look at this here. Can you think of two numbers that when multiplied by themselves, when multiplied, equal 0? Well, I can't unless one of them is 0. So, applying that here, what we're saying is that either x plus 3 must equal 0 or x minus 2 must equal 0. Okay, that's called the null factor theorem, or it's an application of the null factor theorem. So let's work on that. And what we have here is a little linear equation to solve. So what we're saying is that x plus 3 must equal 0 or x minus 2 must equal 0. A bit squished there, sorry. So therefore, subtracting 3 from both sides, we have x equal to negative 3, or adding 2 to both sides here, x equals 2. Okay, that's a 2 there. Okay, so two answers, and we would expect two answers in a quadratic equation. Sometimes there are no solutions, and sometimes there's one solution, and we'll see an example of that later. Okay, our second example, we're solving for x as usual in this case, where x squared minus 2x minus 8 equals 0. Okay, so it's clearly an equation of that form, and where a is equal to 1, that comes from there, the coefficient of x squared. B is equal to negative 2, sorry about that line there, it shouldn't be there. B is equal to negative 2, and C is negative 8. Alright, using the PSN method, the product, of course, is the coefficient of x squared times the constant term there, the negative 8. So it's 1 times negative 8, so it's equal to negative 8. The sum is simply the coefficient of the middle term. Now, remember, the sign belongs to the term on the right, so b is equal to negative 2, or the sum's equal to negative 2. And our numbers in our guessing game are negative 4 and 2. So you can list all the factors of negative 8, and you'll come up with this. So negative 4 times 2 is equal to negative 8, and negative 4 plus 2 is equal to negative 2. And remember, it's very easy once we got to that stage to factorise the left-hand side, so that we've got x minus 4, see that minus 4 there, just comes down, and then x plus 2, so 2 is positive there, so it's x plus 2. And then again, by the null factor theorem, we've got this simple pair of linear equations to solve, such that x minus 4 equals 0, or x plus 2 equals 0. So adding 4 to both sides, we get x equals 4, or subtracting 2 from both sides on this equation, we get x equals negative 2. So once again, we've got two solutions. Okay, let's have a look at example 3. Take a bit of the scaffolding away. So what's our product here? Well, it's the coefficient of x squared, which is 1, multiplied by our constant term, which is negative 60. So it's equal to negative 60. What's the sum? Well, simply the coefficient of the middle term. And by the way, of course, it assumes your equations are arranged in this order. The x squared term, followed by the x term, followed by the constant. Anyway, so our sum is negative 11. And so what two numbers have we got here? Well, unfortunately, 60's got a lot of factors. The negative 11 is suggesting that there's a bit of distance between the two factors. Also note the negative 60, the product, is going to suggest that, well, is going to tell us that one of the numbers must be negative, because remember, a negative times a positive will be a negative. Two positives, if the numbers were both positive, we'd end up with a positive, or if both numbers were negative, we'd end up with a positive as well. So one must be negative. And this negative, the sum of negative 11 here is telling us that the larger of the two numbers in magnitude must be the negative one. I'm thinking of 15 and 4 at the moment, so let's just write that down, 15 and 4, and let's check it out. Okay, so the larger of the two in magnitude must be negative, and let's see if it works. That times that, the negative 15 times 4 is definitely equal to negative 60, and the negative 15 plus 4 is definitely equal to negative 11. So they are our numbers, and our work is nearly done. All we need to do is write a negative 15 in there, negative 15. It's not writing very well for some reason. And plus 4. Okay, so therefore what? Therefore, x minus 15 must equal 0. Or x plus 4 must equal 0. Therefore, x equals 15 or x equals negative 4. Okay, I haven't pointed out yet that if we was to substitute our answers back into the equation, we would find that our equation should be true. So if I let x equal 15 or x equal negative 4 and substitute it back in here, we should find that x squared minus 11x minus 60 does indeed equal 0. I'll allow you to do that by yourselves. Okay, let's have a look at this one. No scaffolding now, so I've got to start from the very beginning by myself. Alright, so what's our product? I'm going to need some space up here, I feel. So product is equal to 1 times 25. So the product is equal to 25. P equals 25. And the sum is equal to the coefficient of the middle term, so that's 10. And now I've got to think of two numbers that when times by that when multiplied give me 25 and when added give me 10. The numbers up here are suggesting that both are positive, aren't they? And we're going to find that, 25 doesn't have many factors. Itself and 1 is one pair, and the other pair is 5 and 5, isn't it? So our numbers are 5 and 5, both positive. 5 plus 5 is equal to 10, that gives us our sum, and 5 times 5 is 25. So what I do, in the usual way, is write down our numbers as follows. And we can see that really there's two ways of thinking about this. Firstly, x plus 5 times x plus 5, well that's just a perfect square, isn't it? So really we can write it in factorised form like that. And then what we can do is take the square root of both sides, and so we get x plus 5 equals 0, therefore x equals negative 5. Okay, so that's our answer. So there's only one answer in this case. Remember I said that before that a quadratic equation will either have two solutions, one solution, or no solutions. So that's a case where it just has one solution. Okay, it's time for you to have a practice at sum. I've got 6 examples there that should, if you can do them, be all you need to know about quadratic trinomials at this stage. Just press pause now, and when you're ready to see the answers, press play again, because they'll be on the next slide. So here are your answers. You might want to press pause while you see how you went. Just to let you know that there are graphical applications of what we've just been doing. We solved one equation early on. It was x squared minus 2x minus 8 equals 0. Well, if we replace the 0 with y and plot the equation, we end up with a parabola like this here. Sorry, I meant to use my highlighter. Parabola here. And what you're going to find is that the solutions you found to the equation you solved, or I solved, are x equals negative 2 and x equals 4. So the solutions represent the x-intercepts. Remember we did one, or I did one, and it was x squared plus 10x plus 25, and our solution, I said there was only one solution, and it was negative 5. In that case, perfect squares, if you plot a perfect square, what you're going to find is that you have a toucher. The parabola is going to touch the x-axis once and once only. So they're not x-intercepts as such, the axis is a tangent to the parabola. Okay, so that's the graphical implications of what we've just been doing.